Yeah, so welcome everyone to our today's session. So today we are looking at introduction to machine learning, and maybe I would just like to hear from you colleagues. When you hear about machine learning, what is it that really comes into your attention when you hear about machine learning? What is it that comes to your attention? Yes, George, what is it that when you hear about machine learning comes into your attention?
Okay, from the two words, machine and learning, we can what comes into my mind is that we are trying to put some knowledge into a machine. So machine will have a knowledge base that will help it learn either based on a certain environment or certain features that we want it to perform.
Yeah. So that's really nice, George and Godfrey. We can't hear you if you're talking, Godfrey. We can't hear you. Or George, you can hear Godfrey?
No, I can't hear him. Maybe he has
Okay.
side.
Yeah, Godfrey. So just find a way if you are unmuted and we cannot hear you, maybe you leave and come back. We will give you an opportunity for you to tell us what comes to your attention, what comes into your mind when you hear about machine learning. Godfrey. So yeah, so George, as you have just said, machine learning comes from two words, machine and learning. Yeah, so Godfrey,
Can you hear me now?
yeah, we can hear you now. We can
I
hear
had
you
a
now.
problem with my
Yes.
mic. Sorry for that.
Okay.
So I agree to George. What I would
Yes.
ask is we're teaching the machine to make predictive results with the data that we're feeding it. So it's able to predict a future result or a result based on the data that we have.
Yes. Okay, Godfrey. Thank you for that. So let me start sharing my screen. That's very interesting to hear from the rest of the team. So let me start by sharing my screen and yeah, so today I'll be sharing that window. So I don't know if you can see my screen. Yeah.
Yes, it's visible.
Yes.
Okay, thank you. Okay. So I just want to build on what you colleagues you've just said about machine learning. So machine learning is a subset of artificial intelligence, what we call AI, that enables systems to learn and improve from experience without being explicitly programmed. So it involves the development of algorithms that can identify patterns and make decisions based on the data. So that's what actually the combination of your input brings it at home. That machine learning is a subset of artificial intelligence, where we enable systems to learn and improve from the experience, learning without being explicitly programmed. Yeah, and it's very interesting part to learn, and you come to realize that majority of the innovations in artificial intelligence are as a result of machine learning, and we have another subset of this that we call learning, deep learning, which involves the utilization of artificial neural network to be able to predict, to be able to mimic the human neurons, because we understand that we have billions and billions of human neurons in the brain. So the deep learning enables us to develop algorithms that mimic human brain, what we call artificial neural network. So that's what artificial machine learning is. So it's just a subset of artificial intelligence that enables systems to learn and improve from experience without being explicitly programmed. Okay, so we will proceed to the key concepts. The first concept is supervised learning. So this is a type of machine learning. The first type of machine learning is supervised learning. So the supervised learning is where we train a model. So a model is trained on labeled data where the input and the desired outputs are known. We are supervised. We know the input and the desired outputs. The desired output, we know them. So we can do this by either classification or the use of regression. Classification is where we classify the outputs. Into either a nominal state or an ordinal state. When you learn about categorical variables, classification is actually about categorical variables. Yes, that is the term. So categorical variables has nominal, ordinal. So of course now either nominal or ordinal can either be binary. Binary means that we are dealing with the two categorical. Is that one categorical variable but has two outcomes? Yes, and these outcomes, when these outcomes are ranked or are ordered, we call it ordinal from the word order. And then when the two outcomes, or two or more, definitely, outcomes are non-ordered, they are not ordered, unordered, or unranked, we call them nominal type of variables. And then when we have scale type of outcome variable, the output variable, we use regression. Multiple linear regression and stuff like that to predict continuous values actually. So in terms of classification, we also have a type of regression which we call which we call a logistic regression that we use also to do classification. But whenever we have continuous variables, we make use of either simple or multiple linear regression. We have other types of regression. We have lasso and so many others. So we can use that to predict the house prices, the stock prices, and stuff like that. The second type is unsupervised learning. Unsupervised learning is where we train a model on unlabeled data. And it tries to find hidden patterns or intrinsic structure. So the type of unsupervised learning, in unsupervised learning, we have two types: clustering or dimensional reduction, which we usually call PCA. So in unsupervised learning, here we deal with, let me start with clustering. In clustering, we group the data points into clusters. Clusters, that means that things with similar properties. If there are images of a cat, we put all the images of a cat together. We put all the images of we put all the images of a dog together. And now when we provide another image from outside, unlabeled, you see, unlabeled. We don't know which image is this. And then now the unsupervised learning will be able to tell us that this is a dog and not a cat. So that's what we call some examples here are like customer segmentation. This helps us to understand when we get a new customer, is this customer likely to buy this product and buy that product and buy that product based on the previous behavior of the customers. And we have dimensional reduction. This enables us just to do feature engineering to reduce the number of features or increase the number of features depending on which type of dimensional reduction are we conducting. So that we can do appropriate model variable selection. And then now we have semi-supervised learning, where this is where we use the mix of the two. We make use of the labeled and unlabeled data to improve the learning accuracy. So once we have already understood the supervised and unsupervised, so semi-supervised is where we use the two together in order to improve the learning accuracy. And then we have reinforcement learning. Reinforcement learning, the model learns by interacting with an environment. So receiving rewards or penalties based on the actions. So in the reinforcement learning, unlike the other types, where we have prior knowledge about the data, for reinforcement, we learn from the environment. We create a model that the model can be able to learns by interacting with the environment. Where you see some examples here, we have things like gameplay, we have things like robotics, where a robot can detect that this is an obstacle, this is a house. You see, you cannot go ahead and mark everywhere where there is a house. You mark everything that this is a house. Now you should pass here. You see, so it is not possible. So when we have kind of models that we develop in such a way, we should be able to use the reinforcement by learning from the environment. The robots should use things like sensors. Robot has different sensors, like sensors for light, sensors for even smell, sensors for distance, and cameras on it and stuff like that. So it's very interesting. And even autonomous driving, like you hear about vehicles driving themselves. Why do vehicles drive themselves without the driver? How is that possible? It's possible through reinforcement learning, where it learns from the environment. It learns from the environment. This is the road and not this. This is the way to go where I want to go and stuff like that. So those are the 4 types of machine learning. And of course, in this session, which is just a scratch on machine learning, we'll be looking at supervised learning type, which we will be able to implement. Okay, so we proceed to the essential components of machine learning. Essential components of machine learning. In the essential components of machine learning, we require data. We require data. So this is the foundation of machine learning. So data should be clean, relevant, and sufficiently large to increase our model accuracy. And types of data that we can have structured tabular data is what we call structured. We can have unstructured data, things like images, visuals, the texts. So, and semi-structured things like the XML and the JSON files. So our machine learning models can be able to learn from the experience from the data that we feed it. So the key concepts of machine learning, the first one is the availability of data. So the data should be clean, should be relevant, and also should be sufficiently large. The second one is features. So features, these are the variables. We call them features. These are the variables, attributes, or properties used for making predictions. So we do something we call feature engineering, which involves processing of the which refers to the process of selecting, modifying, creating new features based on existing features, like creating new variables based on the existing variables, so that our prediction can be as accurate as possible. The third thing is about the model. So this is the algorithm that learns from the data. So algorithm that learns from the data to make predictions or decisions. Some common algorithms are like the linear regression, logistic regression, decision tree, random forests, support vector machine, neural networks. We've looked at some deep learning where we use the artificial neural network to be able to mimic the human neurons for prediction. And then the fourth thing is training. So from after having the model, the algorithm, you train it based on the data that you have provided. So the process of teaching the model using the training data. So this involves the optimizing the model parameters to minimize the errors. So you train, you do feature engineering. This process is not always straight. It's a back and forth process. It's a back and forth process. So every time you will come to realize that maybe you added a feature that is not relevant, you have to remove the feature and stuff like that. And then the fifth one is evaluation. Every time once we build our machine learning model, we should be able to evaluate how it works, its functionality. So that involves checking at its accuracy in terms of prediction. If it is classification, we should also be able to check at its accuracy. So there are different ways of checking the accuracy of our model. Things like the use of the mean absolute error and the mean squared errors for the regression, and things like precision, and how precise is our prediction. And then the steps here is to define the problem. So you have steps in machine learning project. First of all, you start with defining the problem, and that means understanding the problem and determine the goals of the machine learning project. The second one is to collect data. So you gather relevant data from various sources to improve your model accuracy. You process the data. That involves the process of cleaning and prepare data by handling missing values, checking for outliers, encoding categorical variables. Some of the things here we'll be able to handle them in this practical class. And then we have exploratory data analysis, where you visualize your data, summarize it to understand patterns and relationships between your variables. And that can be a good way of looking at your data. And then from there, you select the appropriate model. Once you do exploratory data analysis, but it's usually recommended for you to know how are you going to model your data before collecting even the data. As you identify the problem, you need to first of all understand how you're going to handle your data in terms of building which model, so that you can collect sufficient data that is relevant. Not every data is relevant. You need to ensure that the data collected is relevant to the problem you want to solve. So you choose an appropriate algorithm based to the problem type. Yeah, so if it is classification, if it is regression, and etc. From there, now you train the model. So you split your data into training and testing sets. Then you train the model on the training data. Then from there, now you evaluate the model. Evaluate the accuracy, the performance. Evaluate the performance of the model. So based on the testing set data that you put aside, and evaluate its performance from relevant metrics. Tune hyperparameters. So this means that you may improve the performance of the model based on how the model accurate is. If some variables are in the model and are not relevant, you have to drop them. You have to source for other variables, including creating new variables or features from the existing variables, which we call feature engineering. And from there, now you can deploy the model. That means that you integrate the model into the production environment for real world use. This includes development of applications that use machine learning model that you figure out. If it is any model, like for example, if it is in agriculture, you've developed a model that detects the pests and diseases on the crops, on a particular crop, or to determine which type of variety is this for this particular plant, and stuff like that. So you deploy that by developing an application, because for you to interact with the user, you either develop a web-based application or a desktop application or a mobile application and stuff like that. So all these things Remember, machine learning model cannot be relevant when it is on its own. It has to be in a user-friendly manner. So you have to work together with developers for you to be able to develop accurate the tool that can interact directly with the users. And then from there, you monitor and maintain. Continuously monitor the model's performance and update it as needed. Like in other scenarios, you come to realize that majority of things, if your model is attributed to effects from maybe change of climate, maybe global warming, so you need to continuously synchronize your data to ensure that the model is as accurate as possible. The common challenges that are as a result of this is overfitting. This means that the model performs well on training data, but poorly on testing data. That's what we call overfitting. So the model should not be overfed with the training data, but it works poorly on testing data. So the mitigation here includes cross-validation, regularization, and pruning, just like the pruning we do in agriculture. So we do pruning in data. Then we understand underfitting. Underfitting is where the model is too simple to capture the underlying patterns in the data. So data is not sufficient for modeling. So mitigation here, of course, depending on the problem you have, you choose the appropriate model that is appropriate. Not every model is as accurate as possible. Every model has different accuracy. So you have to look at which kind of problem is this and which model is it that is accurate. Okay. Then from there, data quality. Okay, poor data quality, poor quality of data can lead to inaccurate models. That's very true. We must ensure that the data we are using to train our model is clean and is a representative. That's the definition of a sample. A sample is a representative of the population. So the data that you use to train your model should be a representative. And then we have bias and variance trade-off. So, of course, some of the things you need to consider is about biasness in our data. When you're building a machine learning model that you need people to rely on, should not be biased. So the mitigation here is to find an optimal balance through cross-validation and model tuning. So you need to ensure that everything is balanced. Okay. Those were some of the key concepts and types and common challenges that we face in machine learning. So we go to the tools and libraries that are usually used. So we have Python and R are the most popular in this sector of machine learning. And of course, you can use Stata, you can use SPSS, and any other tool. We have Julia, we have Jasper, we have Jasper. We have a lot of tools that you can be able to use to model machine learning models. Okay, then libraries and frameworks. So in Python, we use skitlearn, we can use TensorFlow, we can use Keras, we can use PyTorch, Pandas, NumPy, Matplotlib, Seaborn. Majority of these we've looked at them, but maybe probably today we'll be using skitlearn. But yeah, that's what we're going to use today. For R, you can make use of Caret, Random Forest, E1071, and ggplots. These are just some of the things that you can use, libraries you can use to model your data. Integrated IDE, which is the integrated development environment that you can use, Jupyter Notebook, PyCharm, and RStudio. Those are the popular and friendly. We have also Google Colab, and we have cloud platforms also that we can use, like the AWS, SageMaker, and we have the Google Cloud AI, and we have the Azure Machine Learning for Microsoft. Okay, then we proceed to applications for machine learning. So how does machine learning work? How do we use machine learning? Machine learning, we use it in healthcare to predict the disease prediction. Medical image analysis, this is in medical engineering. We use machine learning to do medical image analysis. And then we do personalized medicine. Of course, we can know which type of medicine this person is supposed to use based on the people with similar characteristics prior historical data. And in finance, we use it to detect frauds and algorithmic trading. That's things like forex, things like yeah. I don't want to mention some like Aviator and stuff like that. Yeah, so these are just machine learning. And then we have credit scores as well, credit scoring. And then in marketing, we use that for customer segmentation, recommendation system, like in Netflix. Which movie are you likely to watch next? We recommended to you based on your previous movies. So recommendation systems use machine learning, which is a subset of artificial intelligence. And then from there, we have sentiment analysis. So we can be able to analyze and structure data from tweets on Twitter, on Facebook, comments, analyze these things in marketing, campaigns, and stuff like that. In manufacturing, we use it to do predictive maintenance, to know how frequently should we do maintenance, and how can we predict that there is a fault. For example, in oil pipes that are under the ground, how can we know that there is a spill? So we should be able to detect that using artificial intelligence, which is machine learning, and then predictive maintenance and driver behavior analysis and stuff like that. So these were the key concepts of machine learning. So machine learning is rapidly evolving field with vast potential to transform various industries by enabling data-driven decision-making and automation. So maybe up to that point, I would like to hear from you, colleagues, what you've grasped from that introduction to machine learning. So, yeah. George, now how is machine learning?
Well, I think currently machine learning is widely used in so many applications.
Yes.
Because I think we have so many data available at disposal. These apps we are installing in our phones, they are collecting data without our knowledge.
Yeah. There's a lot of data.
Yeah, so we have so much data out there. So
Yes.
and these guys are using machine learning at their to do their marketing, to come up with new products. So I think it's a good field
Yes.
with heavy terms.
Yeah, is growing. Actually, it's the basis of AI. It's the basis of artificial intelligence.
Exactly.
This
Yeah.
is the core. Yeah.
Mhm.
When you combine it with deep learning, so it's in depth. Yeah. Okay. Thank you so much, George. Maybe Godfrey and then Irene.
Yes. I'm just eager to know how it works because I happen to know it's done in marketing and credit scoring, as you have stipulated. I just want to know. I'm eager to learn how it's mostly used to make decisions.
Okay.
Yes.
Godfrey, thank you. Irene, welcome to our today's session. Irene, if you're talking, we cannot hear you. Unmute, please. And the floor is yours for you to comment. You just met us while we were doing introduction.
Yeah. Eh,
Yes, Irene. Yeah, so Irene, you let us know when you're back. I think you are sorting some background noise. Yeah. So, but we would like to hear from you. Maybe you've ever heard of machine learning, and also the introduction you have done. How do you find it? Okay. So we'll proceed, but the flow will be back to you in a few. So let's go to our objective today, and our objective today is to look at binary logistic regression. So let me go straight to introducing what binary logistic regression is, and from there we will have a basis. So in our today's session, we are going to look at a public data set, which is about Titanic data. For those who have watched Titanic movies, so Titanic disaster. So that's what we are going to discuss today in our machine learning model. So, okay. So binary logistic regression is a type of regression analysis used when the dependent variable is binary. Of course, we said that the determiner of which model to be used is the output variable. So binary logistic regression is a type of regression analysis used to when the dependent variable is binary. That means that it has two possible outcomes. So in the context of our model here today, we are looking at the dependent variable, which is survived. So who will be able to learn more about that, which indicates whether a passenger survived, which is represented with 1, or did not survive, is represented with 0. So the key concepts in the binary logistic regression, a lot of things here are theoretical. There's a lot of mathematics behind machine learning. So if you're into machine learning, definitely you have to meet these algorithms. How it's good to understand the background, the behind the scene for these models. So we just like the way we looked at regression analysis, because this binary logistic regression is part of regression analysis. We looked at multiple linear regression. So this is the binary logistic regression. So here we can see that logistic regression model predicts under the coefficient. I'm reading under the coefficient, key concepts and the interpretation. So the key concepts, we have the beta. Beta was standing for the coefficients and the odd ratios. The beta and the odd ratios, the coefficients and the odd ratios, the exponentials of the exponential of the coefficients, what we call the odd ratios. We are going to look into that into details, how we interpret. And then the logistic regression model predicts the log odds of the dependent variable as a linear combination of the independent variables. Just as we can see here under logit function here, we can be able to see this is like a linear combination. This is a linear combination of the independent variables to predict a dependent variable. So the dependent variable has two outcomes. So the first outcome, 1, which is yes, which is success. The probability of success is usually represented with P. The probability of failure is represented with Q, which is usually just 1 minus P, each having a probability of 50% probability. So that's why you will see when we'll be basing on the interpretation, we will have 0.5 threshold value, that default threshold value that help us. It's not p-value. This is threshold value for binary logistic regression. So p here stands for the probability of an event occurring, and then 1 minus p is the probability of an event not occurring. Just as you can see here, that p is the probability of the event occurring, which surviving. So the logit function transforms the probability into log odds. It transforms the probabilities into the log odds. There's a lot of theory, so I will not be able to dive into it right now because we'll be having a lot of practical. And then from there now, we would like to have the odd ratios, which is the exponential of the coefficients. which gives us the probability, the prediction, which ranges between, the p-value ranges between 0 and 1. P-value, the probability value here ranges, the probability of success, event occurring, not p-value. It ranges between 0 and 1. Yes. And then the predicted probability is obtained by transforming the logs back to the probability scale using the logistic function. So we'll just go straight to the example with the Titanic data. So just check your LMS for the data set, and let's get started. Check LMS for your data set. Let's get started. Let's dive deep into this. So Irene, if you are there, maybe let's download the dataset in the LMS under my introduction to machine learning, and let's get started. Irene, if you are able now to mute and tell us maybe what is your perspective about machine learning.
Can you hear me?
Yes, yeah, we can get you. Thank you so much.
The introduction was okay, and it's very interesting that machine learning is applied in a lot of things. Yeah, looking forward to the practical bit of it.
Nice, 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 Irene.
Yes.
Thank you. Thank you. So let's pull the data from the LMS. I like using pull the data. It's like we are pull and push like in the GitHub. Yeah, so let's pull our data to our local machine. Once we have done that, let me know. The data, just confirm that it is known as Titanic dataset. And let's dive deep into it. Yeah, I am just being notified that the material you will receive, this is the final project for your Python learning. You can do more with the data apart from the problem statement that we have given you, but our core is to focus on the problem statement. So material has just been uploaded 1 minute. So we'll be working on that. So we'll give you, we understand within our busy schedule. So can give you like 2 weeks for you to submit your work, because it will also involve doing research, more and more things that maybe you did not get them in our class, so you have to do more research about them. That is the interesting part of working with projects. You learn a lot, learn along the way. Once you have the foundation, it's easier for you to navigate you are learning. So are we having the data? Let me just know. Let me know.
Yes, yes.
Yes, Godfrey, do you have the data? You're on mute. Irene, do you have data?
I'm using another machine. I was trying to download an account on it. It's still downloading, but I still
Okay. Okay. So Irene, do you have the data?
Yeah.
Okay, thank you. So we get started. You get started. So because of time, we get started. So let me just go there. So we start introduction to the Titanic data. We start by looking at the Titanic dataset provides information on the passengers of the Titanic, including whether they survived or not. So here are the main features. The first feature is the passenger ID, which is a unique identifier for each passenger. We have survived, which is just survival, as 0 to represent the person did not survive from the Titanic disaster. and yes, 1 for yes, that the person survived. So we have the ticket, class tickets. Class tickets, so we have first class, second class, third class, represented with 1, 2, 3, respectively. We have passenger name, the name of the passengers who were on board, and then we have the gender, male, female, and then we have the age in years, and then we have if they had sibling or spouse on board in the Titanic, and also we have the number of parents or children that were also on board, and then we also have the ticket number for the person, and then we have the fare for the passenger, and then we have the cabin number, and then we have the embarked. That is the port of embarkation, which was we have 3 categorical variables there, categorical values there, categorical groups, C, Q, and S, representing the Cherbourg, the Queenstown, and also the Southampton. And then we start now by importing our pandas library. We start by importing our pandas library. So import pandas. So in this, we will just realize that we'll be importing the data as we go by, so that I do not want us to import all the packages at the top, but it's usually recommended that you put all the packages at the top so that we can know which packages did you use. Okay, so after import pandas, so locate where your data is. For me, I am assigning the link to be called Titanic, and then now this is just a new way and another way of how we can import data. You can of course just copy this and paste here and still works the same, but I just decided for this. So once we have this, the data, we call our data that we are bringing as DF. So we may just view some first. Of course, in the next part, we are exploring the data. So after you have loaded your data, we go to explore the data. So we start by looking at the first 5 rows of our data, which is exploratory data analysis. First 5 rows of our data here, we can be able to see the passenger ID, can have to see the survived, you can see the passenger class, the name, the sex, age, siblings or spouse, or parents, they had parents or not, and we have the ticket number, we have the fare, we can say it's in dollars, and then we can say maybe the cabin, and then we can see the embarked column. So that's the view for our data. So we can see here we have numerical data, categorical data, and we can have actually string, something like just a string. So we start by doing exploratory data analysis so that we can clean our data, pre-processing our data. So maybe we just describe our numerical variables. So passenger ID is detected as numerical, so we will not interpret that. The survival rate is just 0 and 1. So of course we expect maximum to be 1, minimum to be 0, and these other things are irrelevant. So count is 891. That means that we have 891 entries under survived, and class 1, 2, 3. So maximum is 1, maximum is 3, minimum is 1, and of course that age. Age indicates has some missing values in it. So we will see how we can handle missing values in our data. And the mean for the age is 29 years, which is around 30 years, and the standard deviation, how far away at the mean, the values, independent observations away from the mean, the central tendency is 14. The minimum is 0. So yeah, maybe there is a misentry there. And of course, we can look at the percentage we call them the quantiles, and the maximum is 80. And then the siblings, the siblings and spouse, information like that, and other information as that for the numerical data. So we've described our data. Now we check for missing values in our data. We check the missing values in our data. Hope we are together up to there, because these are things that we had already covered about exploratory data analysis. So we're just describing, and then now we are checking for the missing values. Let's check here for the missing values. It's just the normal way we usually check for the missing values, but actually you can, because of time, you can check the missing value in the chat section, just to print the missing values in your data. Of course, it's not a must that you use the print, not a must that you use the print. You can just run without using print. And of course, you can see that we have age 177 missing observations. Cabin, we have 687 missing observations. So you cannot try to fix that. So we want to fix this under pre-processing the data. Under pre-processing the data, so we want to fix the missing values. So yeah, so up to there, let's first of all know where we've reached before we go to fixing our data, before we model. So Irene, so far? So far? George, so far?
We are together.
Okay, thank you. So Godfrey, I don't know how you'll do this.
I'm following.
Okay, okay, thank you. And Irene, can we know where you are?
We're together.
Okay, thank you. So we proceed to pre-processing our data. So let's look at some of the things that are important here. So first of all, we start by filling missing values. So it is not always recommended to drop missing values unless the data you are dropping is not important. So you cannot always drop the missing values. So today we are looking at, we are going to look at how we can be able to handle missing values. So the first thing is age. Age had 177 missing values. So for our case, we are using mean. We are using the mean, which was around 30, 29 years, to fix that. And we are replacing in place true. Where there is missing value, we are just replacing it with the mean. So for us to do that, we do the normal thing that we usually do. We call the DF. Sorry, so we call the DF. We call the data, the column in the data. We select the column in the data. The way we usually do that. So I'll just copy share the whole sheet, the whole cell, so that we can all move step by step. By that, it will save time, so that we can have enough time for looking at interpretations. So just check this everything. So we start by, yeah, there we go. So we start by looking at missing values in our age variable. Missing values in our age variable. We started by looking at that. Now we are filling. So we select the column age. We fill missing value, fill null in the column known as age with its mean. Column known as age with its age mean in place true, in the same place. That's the first thing we do. The second thing we do, in the embarked column, we fill missing values. Remember, embarked had two missing values. So embarked is a categorical data. It's a categorical variable. It's a categorical variable. So let's just go. We are replacing with mod. We are replacing with mod. Common appearance, yes. Embarked had two missing values, so we are replacing with the common appearance. That's how we replace using the mod, using 0 index. And then from there now, index 0, which means that we are computing the mod whenever we have a lot of, whenever we have multiple mod in our data, we are going to pick the first mod, 0 index 1, the index, the first position, 0 index, first position in the mod outcomes. And then we are replacing in the same place. And then from there, we go to fair. So the fair, let's see if fair had missing values. Fair, actually fair does not have missing values. But of course, if it could have been the case, we can replace it with the mean. Okay. Then from there, we proceed to drop the cabin column because it has a lot of missing values. Cabin column has 687 out of 891 observations. So we cannot be able to replace everything. Our data will be inaccurate. So what we do, we drop that column in our model. And then we proceed to encode the categorical variables. Remember, we have something we call encoding in data. In tools like SPSS, Stata, you can categorically encode your data. That means that whenever you have something like gender, male, female, you have to change from male, female, which are string, to give them numerical values, integer values, which can either be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But of course, we usually recommend categorical variable that is having a lot of groups into it is not recommended in modeling our relationship. Our model will be accurate. Yeah, so in this case, we are going to select which columns are categorical in our data, the column known as sex and the column known as impact. Column known as sex and column known as impact. So in this case, we are going to do one hot encoding, which we are using get dummies from pandas, a method from pandas for us to replace where there is one with where there is a male to be assigned a value and where there is female to be assigned a value and stuff like that. So we can now proceed. Then we drop. So there is a recommendation on how you can do the encoding. So let me just type here. So for example, we have a variable known as sex. We have a variable known as sex. Just check here. Our variable gender, just sex, male, female. So yeah, we are here. So sex, male, female. So we can assign, for example, 1, we can assign to male, and 2, we can assign to female. This is how SPSS does its thing, and Stata. Those are software packages. But in Python, we are using one hot encoding, where we will create new variables known as sex. We will create a new variable known as sex male, depending on the name that is in the category. Case sensitive based on the category, male. And then we create another variable known as female. Now, under male column, we will be having true or false. We'll be having 0, 1. So depending on which passenger. So when this is 0, that means that the next one must be 1. Under the next value for this must be 1. But of course, it will depend with maybe it's alphabetic. So this female will be the first one, and then male will be the second one in terms of arrangement here. And then where there is 1 here, that means that for female, it will be 0. So that's how it will be working. But now when we specify drop the first is equal to true, that will mean that if our first column in this arrangement is female, sex female, then it will drop this column. So that we will just know that whenever we have sex male, where the value is 0, that will mean that actually it was the person was a male, it was a female, sorry. And then where there is 1, that will mean that that passenger was a male. That's what this code is doing here. Get dummies. We call it one hot encoding. There's other types of encoding, but we are using one hot encoding. I don't know if we have understood that part. Have we understood that part of encoding?
Yes.
Yes, thank you. Then we are going to drop numeric columns that won't be used for modeling. So for example, things like name, things like the ticket number. What are they doing? So they will not be used for prediction. We can drop them here. And of course, we can also drop the passenger ID here in this category. So for us to drop columns in pandas, in Python, we use the DF called the pandas library, pandas method known as .drop. Then we specify columns. We give the column names that we want to drop. And then we say that in place is true. So we'll fix everything whenever we have space, drop, and then combine our remaining data as appropriate. So once you drop this, once you implement this, just run that, and then you check the how everything will have changed. So you see, we dropped female, we have only male here, and we don't no longer have sex. We no longer have sex. We dropped that. We dropped the first the existing. We dropped the existing original column before. We dropped the sex column before. So we have just male, female. So female was also dropped because that is the rule for one hot encoding, the appropriate method of encoding. We drop female. So whenever we see true, that means that this person is a male. And whenever we see false, that means this person is a female, because we only have those two categories. So for embarked, we have three categories. Embarked, we have three categories. Embarked head 3, when you look at our data here, head 3 categories, S, C, and Q, Queen something, Queenstown, yes. So C, Q, and S. So it will also do the same. So we will just know that whenever, let me go there, yeah, here. So we'll just know that this is now 3, there are 3. The first one was dropped, C was dropped. So whenever you have false, we have true. That means that that person is was picked from the Southampton. Embarkation, the point for that person was Southampton. And then whenever we have false, that means that that person was from C, the C category. Whenever we have false. Whenever we have true here, that means that the person was Queenstown. Yeah, and stuff like that. That's what one hot encoding does, so that we can convert our categorical variables that are string to numeric. Hope we are together up to that point.
I'm getting an error.
Where?
When I run that code,
Yes.
an error on embarked.
Embarked.
Yeah, the above exemption was the direct cause of the following error. Key error embarked.
Just check your column. If it is as exact as this, if it has the same name. I don't know, George, Godfrey, not Godfrey, Irene.
Mine is okay. It's
Yeah. Yeah. So George, just check if maybe there is space in between embarked in the quotes here in the code, or check the name if the name is the same as the name in the previous.
The name looks okay.
The original data. So I think check at the I think maybe the embarked should be the first embarked, maybe for your case should be pointing for the first embarked if embarked is the problem. Just check where the error is pointing, and maybe I stop sharing so that you can share. and we see the problem should just be at your end. Stop presenting. Okay.
Okay. You see my screen?
Yeah, it's coming up. Mm-hmm.
So I'm
Just
good.
okay.
This is the
Go
the
down.
down
Go to the scroll
error.
down a little bit. Let's see where the error is pointing. It's not pointing there. It's not pointing there. It's pointing there. The first one. Embarked. The first embarked. Mm-hmm. I don't know how we can help you sort that, because we just see everything there is okay from what we see. Mhm. Maybe can you check the can you insert there a cell at the top, insert a new cell at the top between then can you do df, just call embarked column, like, yeah, remove the dot. Run, let's see. Yeah.
Same error.
Embarked. You wrote
Oh, sorry. Embarked.
yeah. So can you again maybe print your columns? So do df dot columns, just like that. Those are your columns. Okay, you see it already
Does already.
performed. Yeah.
Okay.
Yeah. So
So I was running twice.
yeah, you are running twice. So it
Okay.
was not available.
Okay.
Yeah.
How do you clear the errors?
Yeah, so for you to clear the errors, maybe you have just to select and copy the select and cut the whole sheet, and then run it without anything,
Okay.
and then paste it back. Yeah, the easiest way. Then you paste back your code, so you can just proceed. It had already done the running, so it was not finding you are embarked until you start from scratch by importing the data for it to be okay. Okay, so we can proceed. So we can proceed. Okay. Don't know if you can see my screen. Okay, there we go. Okay, so we have seen the head. So we go to building the model. So before building the model, again, we counter check to see if we have any missing values in our current data. So we just check if we have any missing values in our current data. Just check if we have any missing values in our current data. Yeah, so we don't have any missing values in our data, and the data type here is all are integers. So we can use that to make the prediction. So for me, I still have the passenger ID, so I have to drop it here. we have to drop the passenger ID because we cannot use the passenger ID to do the prediction. So just to drop the passenger ID. So just the same code we had for dropping the other columns like name, but now in the quotation we specify that we are dropping the passenger ID. And then from there now we start by subsetting our data. So that's now building the model. The chat section. So we build the model. So in building the model, from sklearn, which stands for the skitlearn that we are using, so we have to import skitlearn. I think that's from skitlearn we are importing model selection. From sklearn import or model selection. Okay, in sklearn dot model selection we are importing tests, train test split method from the sklearn model selection. And then from sklearn linear models, we are importing logistic regression. Once we have imported the two, we proceed by doing feature engineering. We specify our independent variables will be represented with capital Y, and our dependent variable will be represented with a small y. So we subset our data by dropping survived. We subset our data, original DF, by dropping survived, and we assign it to capital X, which stands for all the independent data. All the independent data. All the independent data. And then after subsetting data, we also we subset the survived to Y, which is the dependent variable. So once we split the data in that way, we have subsetted our data. We now go to splitting the data into training and the testing set. So the arrangement here must be the same. You cannot interchange the arrangement here. So we start by specifying the X train, which will stand for the data that is going to be for the training set, for the independent side. And we go for the dependent side. Still also here is the independent side, dependent side for the testing data. So we are splitting our data, our main data, into training and testing. So we will do that for the data that we subsetted for the dependent and for the independent. Y train, X train, X train, X test, Y train, Y test. And then from there now we say equal to, then we call the train test split method that we imported. And then we specify the independent variable, which is X independent variables, which is X, capital X, which stands for this data that is substituted here. And then Y here stands for the dependent variable. Yeah, this is the independent variable, then the dependent variable. And then the test side, this is the 20% of our training data, or of our whole data set, will be used for testing. This is what this means. The 20%, 0.2, 20% of our data will be used for testing. So it will split our data, 20% testing, 80% of our data will be used for training. And then from there, random state is an argument in the train test split equal to 42. You can specify to any other value, but it's usually used just to ensure that every time we do the selection, the same random elements that are being selected for testing and training remain the same, so that we don't have different outputs whenever we run, because we are doing repeated. We may tend to do, every time we run, we may do repeated running, and we ensure that when we do the selection here for splitting data, we ensure that the data that we select is the same throughout for testing and training. From there, now we create the model. So to create and train the model, so we create the model. We create the model known as logistic regression. So the model will be known as model. which is equal to, we call the logistic regression method from the sklearn.linear models. And then from there, now we fit the model, we train the model by using the trained data, which is the independent variables and the dependent variable. Remember here, we've trained our model. So maybe everyone to run that, so that for if your model is running accurately, so we can have this, we can have this kind of an output.
Just a question, eh?
Yes.
If you go back to that those lines, eh?
Yes.
The X, we are assigning it survived column. What does this
No.
drop?
X, we are assigning it
Mm-hmm.
all other variables in our data except survived.
Oh,
Because
that's what I
survived
mean.
is the dependent variable. So we drop it in the data that we are assigning to X, which stands for the independent variables. You remember in the model,
Yes.
model that we had for binary logistic regression,
Yes.
X, all X's, this side, are represented by capital X there. And Y, which is just one variable, which is categorical, is survived. So that's what we are doing here. So Y is for the survived column, X is for the other columns apart from survived.
I get it now.
Okay. So once we have built our model there, now we can check the model coefficients. So I don't know if we have already reached there, all of us. Do we have, is everything running right?
What is the expected result?
Just this.
One line, eh?
Yeah, like you can, it's a drop down, so it can be one.
Yeah.
There's a drop down here, so it can just be one. No problem.
Mine doesn't have the drop down.
Okay, but once it's just logistic regression, no problem.
Yeah, it's
Depends on the
just
also-
indicate logistic regression.
Okay.
Mm.
So from there now, we have we have determined our model, so we can check the coefficients of our model. The coefficient of our model, to obtain them, we call the model dot coef model dot coef. So the coefficient actually, and the model coefficients. That's what we are calling here. And then we are also calling the intercept of our model, because the model must have the coefficients and must have the intercept, starting from the first index, the index 0, in that arrangement. So once we have that, we can be able now to print the coefficients. Coefficients will be equal to the number of variables that we have in our model. So our model has how many variables? So far where we've reached, we dropped this. Maybe let's check our data. We dropped that. So we only have survived. So we have survived is the dependent variable, so it is not part of the coefficients. So we must have 1, 2, 3, 4, 5, 6, 7, 8. So here we have how many? Is an array. Here are the coefficients 1, not an array, coefficients 1, 2, 3, 4, 5, 6, 7, 8. So everything here represents the coefficient of the presence of that, the other one. Okay. Then we proceed to the intercept. The intercept here is the constant. When all these others are 0, the chance, the odd ratio, not the odd ratio, the coefficient here for the survival is 4.5193. The same way we usually do the interpretation in the regression analysis, we do it here. But in this case, we're going to talk about the probabilities. Here we're going to talk about the probability. These are the coefficients, yes, but these are the probabilities. Now we want to look at the interpretation to probabilities. So interpretation using the coefficients here, it's not that straight the impact that it will have that is straight. Remember, the outcome for logistic regression is only two outcomes, 1 or 0. When the coefficient p-value, the p-value, not the p-value, the probability value, the probability of an event occurring value is ranging between, I think that one should be down there in the interpretation, something down here. So I think we'll look into that. I'll just go there so that we can all see what it means. So when it is less than 0.5, that means that the person did not survive. It's greater than 0.5, that's when you are like the Y output. So when it's greater than 0.5, that means that the person survived. We are going to look at that when we will be outputting, when we will be testing our model using a sample data. Okay, so for us to get the odd ratio, so I'm going to talk about the odd ratios. So let me just ensure that we get the odd ratio. These are statistical things that relate to the, and we usually use it even in healthcare and stuff like that. So the probability of survival. So odd ratio here. So odd ratio here shows the probability.
Share the lines above. Share the
I-
lines above the coefficients. For the coefficients.
For the coefficient, sorry. Okay.
Didn't share.
With the coefficients. Okay. Okay. So the odd ratios here produces an array. So this array is actually representing the coefficients. It's the exponential. Remember the exponential of the coefficients. That's what the odd ratios here are. 1, 2, 3, 4, 5, 6, 7, 8. So these are the exponential of the coefficients. We get the odd ratios. So the odd ratios actually tells us the probability, the chance. So for example, when we talk about the survival, so okay, let's take one sample here. Let's consider something like gender. So gender here, we only have sex, which is male. Male 1, male true. So when male is true, let's check which number is male. Male is which number? Number 5. This is 1, 2, 3, 4, 5, 6. Male is number 6. So this is 1, 2, 3, 4, 5, 6. 0.0751501. Okay. So this means that when a person is female, not female, let's talk about male. When a person is male, which is true, which is 1. When a person is male, 1. So the person who is male is likely, the chances of a person surviving if the person is male is, the probability is 0.075 higher than when the person is female. Remember, when a person is female is 0. That means that there will be no value here for when the person is female. Remember, we dropped female. So that means we only have male can either be 1 or 0, where 1 means that the male is true. So when we fit our model, when we predict and we represent the sex here for male to be 1, that will mean that that person has 0.0751501 chance of survival than a female. These are odd ratios. So you can research more on how we interpret these odd ratios, but that is how we interpret the odd ratio. We are going to look at sample new data, new column. We will just bring a new column. We are not going to test using the data subsetted, but we are going to bring the new column based on the model that we have here to test it if it can predict the survival probability of that person. So these are things that are as a result These are as a result of the model. Things that we use to check the model evaluation, how we evaluate our model. How we evaluate our model evaluation. So once we have our model on the test set, now we evaluate the model based on the test set, where we can be able to produce some values that can enable us to know the efficiency and the accuracy, sensitivity, and specificity of our model. In logistic regression, you will meet a lot of terms there, but we're not interested in the pseudo R. So let me just remove this, but let me just check here. I don't think we're not interested in the pseudo R, so you'll just have to remove pseudo thing that relates to the pseudo R square. So we are not printing it here. So just remove it in your code, but know that pseudo R square exists, just like in the logistic, in the multiple linear regression. Just producing my results again. This is for the coefficient. Where am I? I've given you the code for the above or the code for the below. Hope I'm giving you this code about the model evaluation. Just check so that it can be easier. No, that is not the one. So just ignore the top and take from the model evaluation on the test set. Yeah, we have to evaluate the model performance before we go to the visualization of the results. So here, we evaluate the model. We want to evaluate the model. How is model performing? You have to evaluate your model before deployment. How is it performing? So we evaluate it based on the test data. So we predict, Y predicted, and the probability, Y prob, the probability of Y, and the Y predicted. So we call the model, already we defined the model before. So we just call a method, predict X test, then predict probability from the X test, take the probabilities of the predicted values. So these things you can still further research more on them so that it can be easier for you to understand. It's very hectic for you to explain one by one, line by line on what it's doing, of course, but we are saying that what we do here is to predict and assign that predicted values to Y predict, which will help us to compute the accuracy of the model. So what we want here is to compute the accuracy of the model by looking at the classification report, which relies on the Y test that we had while we were subsetting our data and the Y predicted. Y tested and the Y predicted. Y test and Y predict. And then from there now we store this classification reports in report variable. Then we proceed again and produce the ROC AUC scores. So the ROC and the AUC scores. So these are just scores and the curves that we use to visualize how things are when we want to rely on the accuracy. You can use a lot of options to check for the accuracy. So these are all options for checking for the accuracy of your model. And then from there we produce, these are the variables that we already defined here. So that's why it was important to define them. We are using them here to get these values. And then look at the confusion matrix, which is our 2x2 matrix for like in hypothesis testing, true, false, true, false. So this is true, positive, false, positive, true, negative, false, negative, and things like that. The confusion matrix. We are going to see that and down there, some summary interpretation. It will be easier for us to understand when we reach there. And then from there now we display all these results, but we had already displayed the coefficient, we had already displayed the odd ratios and the intercept. So maybe the thing that should be produced here is just the classification report, the ROC report, and the confusion matrix. So let me just check if I have that interpretation there down there before we visualize that. I think we have that report. Let me just check here if I have some summary, yeah, some summary interpretation. Yeah, I have here, and all these other things are just the repetition of what we already have. Model evaluation is just the one that is just above. So for us to make our work easier in terms of interpretation, we want to combine all these things together. So I'll be able to interpret both, but this is just an addition on what you already have, like to visualize. Let me copy this and paste it in the chat section. To visualize the accuracy, the performance of our model evaluation. So let me just share it also so that we can interpret all these things all together, because it will not make sense if we interpret one and again interpret another same thing. So the next part here, we want to visualize the performance of our model. So we import matplotlib, we import Seaborn from skitlearn metrics. We are importing I think you don't have this ROC curve imported already in the above code. Yeah, so this sheet was just about was supposed to be on top of that. So that's just arrangement of that. But I think you already have this. So when you run this first and then run the top one, you'll be able to get the correct answer, or else you'll get an error here because we don't have this method already imported from sklearn. And then from there,
On the top one.
yes, for the top one, you have to run this. You have to have from skitlearn metrics import rock curve. Imported.
On the top, you have left some 2 lines. The rock aux score is not complete and confusion matrix is missing.
Okay.
The 2 lines, just the 2 lines.
Oh, the 2 lines, the bottom one.
Yeah, the bottom one, yes.
Okay. Because these ones rely on the code below. Let me see if I have them here. They rely on the code below. So maybe let me cut them here. They rely on the code below. Just check here, everything. Yeah, they're not above, they're not here. So they rely on the code below. The code below is this code here, where we are computing this. So I can have them in between here. Yeah, where we can be able to print the coefficient matrix. I think coefficient matrix should just be above. It is just this classification report under the other report. Coefficient matrix is just okay when it's at the top. Yeah, so confusion matrix is just, yeah, should be there to the top. Let me run this again. And let me just copy this afresh so that you don't get any error because you have not imported some other packages that rely on that. So just have this first, where you can be able to see. Let me just explain something here before we proceed to the visual. So the intercept we had, the coefficients we had produced, the odd ratio we had produced. Something that we are producing here is the confusion matrix. Truth positive, like predicting something to be true, predicting that this passenger, okay, predicting that how many passengers that were correctly predicted that they survived 89. How many passengers were wrongly predicted, okay, were correctly predicted. Let me just check the confusion matrix here. You see this, let me check the confusion matrix. Yeah. How many true negative, that means that how many people were correctly predicted to be negative. Let me just check. You see, when it's arranged like this, it confuses everything. So I just want to help you understand the confusion matrix, because when it's in this way, it is already confusion, is already confused. So let me just check so that we can interpret it. It's supposed to be a 2x2 arrangement where we have this here, this one is here to the top, false positive, and then we have false negative, and then we have true positive. Yes, true positive. Okay. So what we are trying to do here is that we are creating a contingency table. How many people were correctly predicted that they did not survive? How many people were falsely predicted that they survived? Positive, they survived. 60.
Emmanuel,
Yes.
maybe you can kindly share the cell that had the model evaluation and the one after for import matplotlib. I think I didn't grasp it.
Or for matplotlib, I will reshare it again. But we are looking at, I'm just going down so that we can see how to interpret the confusion matrix. Do you have this one, model evaluation?
Resend it kindly.
Okay. Okay.
I think what you need to do, maybe I don't know, you resend everything. We got confused a bit.
Okay. So
Or the
okay.
original one before you left the confusion matrix part.
Okay. So I just want you to let me just check where everything was okay before we went there. So extrain info this just was to check if the variables are correct. So do we have the odd ratios? Do we have the calculate odd ratios?
Yes.
Okay. So once we are there, we go to this cell, the model evaluation. Once we have the odd ratio, we go to model evaluation. So we are still just printing the odd ratios here together with the confusion matrix. So, and even this code is also here. We've defined the reg, so we just need to print it. Let me just help you out. So before I share with you, let me just check because that variable is there at the top. We have already, again, we are also doing it here, the rock. So there's no need for it to be at the top. And I think it's just that. It's just that this is just a repetition of what we already have. So yeah, it's just that. Okay. So it's just that confusion matrix and stuff like that. Yeah, so it's just that. So maybe I copy this that covers everything together. It's a model evaluation together. Let me just drop this from this. We are not printing it, and then share it. So I want to send it in the chat section so that we can all know. Let me see. Send a message before. Oh, start here. Start here. So that we can know. So let's have that. Let's have that. Just confirm with me that it's okay, it's running at your end, so that we can all have.
So we should paste that after coefficients.
Yes, after the odd ratios.
Okay.
After the odd ratios, we go to model evaluation, which is still also producing the coefficients here together with the confusion matrix. What is just different here is the confusion matrix alone. And report.
Getting an error from my end.
Yeah, where exactly?
The classification report is not defined.
Yeah, so drop. Yeah, I'm just also checking that classification report. It must come after we have imported. I think I rearranged these things. We should come after we have imported this. So just delete that message for classification report. So remove it there.
Mhm.
Just that. Remove that classification report information. It will come later here. I will send this. It will be reliable. So how is it?
Still claiming confusion matrix is not defined.
Confusion matrix. Confusion matrix is equal to y predict is equal to confusion matrix. Okay, you have to import. Okay, let me help you out. You have to import confusion matrix method, which is here, which is imported here. So this line, confusion matrix, this line. Okay. So let me help you out. Let me send you this. You import it completely. You import this package that contains everything completely. Import this package from sklearn matrix, import accuracy score, import precision score, import recall score, import rock, that score, confusion matrix, and classification report. So import that before, just copy it and put it at the top of your code, of your cell code, and then run. And then from there is when now we'll be able to use the classification and the other ones later. So just
Now,
let,
now it's okay.
yes, yes. So just copy that, run it together with your code, because we had not imported for your end. You know, from my end, I imported it while I was coding down there. So it was running because it had already been called. So for you, you have to call it first before you run. So Irene, is it okay?
Yeah, it has run.
Okay, okay, okay. So we are importing, let me start from there. We are importing from sklearn.metrics. We are importing accuracy score, precision score, recall score, rock score, confusion matrix, and classification report. So this classification report and this we will, and these others, we will meet them in the next part. So let's first of all talk about the confusion matrix. Let's talk about the confusion matrix. So this is the confusion matrix you're talking about. Don't mind me skipping here to here so that you can understand the confusion matrix. So the confusion matrix provides a detailed breakdown of the model's prediction. So this is how it is. So let me see if I can draw something on the screen with annotation. So let me annotate pen. So confusion matrix is like this. So let's say I have something like this. Yeah. So it is prediction. It is prediction. What is it that has been correctly predicted negative? 89. 89 predicted correctly negative. True negative. 89. Correctly predicted to be truly negative. TN. This is what we call TN. This TN. TN. Don't mind TN. True negative. True negative. Then we go to false positive. So here is true, false. So false positive here is 16. How many were predicted false? How many were predicted that they died and they did not die? 16. That's what it means. False positive. They died and they did not die. False positive. They died and did not die. And then we have false negative. False negative. Those who were predicted to not that they did not die and yet they died. False negative, 20. So it's a confusion matrix, 20. And then, sorry, 20. And then we have 54 true positive. Those who are correctly predicted that they truly survived. 54. Yeah. Confusion matrix. Yeah, so something like that. So you have to research in depth on the confusion matrix for you to be able to understand it better. So let me clear all. And that's how the confusion matrix looks like. So the rows represented the actual class label 0 and 1. And the column represent the predicted class labels, actual and predicted, 0, 1. So for example, the cell 1, 1 contains the true positive, correctly predicted positive instances. Correctly predicted positive instances. And stuff like that. So we can understand more about this when we look at the confusion matrix in depth. So this is just an introduction to machine learning, but we can go in depth to understand how confusion matrix works. And then we can have the classification report. So classification report is where, let's go to our code first of all, see what we had in our output, what have we not discussed. Let's go to our code. Yeah, only that. So once we come from there, I want us to produce these reports before we see the visualization. We look at the accuracy of our model. So I want to share the code for the accuracy of our model. We defined this. Y predict, we have it, I think. So what we just do is the classification and the matrix. The confusion matrix, you already have it. So it's just this part. Yeah, so just want to combine that and then cut and then share with you. Sorry, where are you going? Yeah, so recall, because the others and the classification report. So you need this, cut this, paste here, and copy this, accuracy of the model, recall. So these are options for you to check for the accuracy of a model and then calculate. So let me just copy it so that I don't cut it. When I cut it, it will, okay, let me cut it, copy, cut it, and then paste it in somewhere, another cell, and then share with you. So that, yeah, my things look ordered. So I just insert a new cell down there, down below that, and I paste it here before I share with you. Yeah, so Control F. So we calculate the matrix. So we calculate the matrix down there. So there we go. Hope everything is pasted. Yeah, calculate the matrix. Yes, yes, yes. I think everything is there with you. So here we check at the accuracy, precision, recall, confusion matrix. That one we had already looked at, confusion matrix. So what we are doing here is to check the accuracy of our model. So we take the Y test, that is the Y test and the Y predicted. Y tested and the Y predicted. And we check if our model is correctly predicting our outcome. What is the percentage of accuracy of our model? We can also check at the precision, how precise is our model. And then REC scores, you can further look at this. This is an advanced way of also looking at the accuracy of our model, how model is working. Confusion matrix, we have looked at it. Report classification, we want to run that and see it, how it is. So let me just run this. So when I run, I get this output. Accuracy of our model 0.78888. When I correct this to true significance, figure is 80%. So you can say that our model is 80%, correctly predicting 80%, the accuracy, correctly predicting 80%. That is the correct prediction of our model. How sensitive is our model? How precise is the sensitivity of our model? 0.77. We are going to look at those values in the here down here on how we can its interpretation is here. And then classification report is just the overall report about the precision, about the recall, and the F1 score. So we are going to read that here, and we will be able to understand everything on how to interpret. And once we finish this, we will be done for our session today. And then we will predict, we will see how we predict here, before we finish. So let me just run this so that we can have the interpretation. So the accuracy. So this matrix represents the proportion of correctly predicted instances, both true positive and the true negative. Like correctly predicting that these people died, and yes, they died. And also correctly predicting that these people did not die, and they did not die, like they survived. And then out of the total number of the instances, So in your case, in our case here, so the model's accuracy is approximately 79.89%. So which indicates that it correctly predicts the outcome for about 80% of the data point, which is a good performance of a model. A model should, if a model is a good performance, should have a score of 80% accuracy for the model to be accurate. Precision measures the proportion of the positive prediction, correctly predicted positive instances, out of all positive prediction, both true and false positive. So you can just look into details. I'll share this so that you can be able to look at it in depth. Right now, you may be confused because of the confusion matrix. And then the higher precision indicates that the model is better. So it's better at avoiding false positive. The sensitivity of our model. So in our case here, the precision is approximately 77.14%. Which is a good value to rely on. So this is an advanced interpretation of how you can use recall also to make interpretation. So it indicates how well the model captures positive instances, which is approximately 72.97%. And then confusion matrix, we've looked at it. So maybe we look at the classification report. The classification report summarizes the precision and all this in both classes. 0, which means not survived, 1 means survived. So the weighted average for the F1 score is 0.80, which indicates that the overall performance of the model across both classes. This indicates the overall performance of the model. So our model correctly predicts 80%, as we said. So we remember that these metrics provide insights into different aspects of the model. So we must just know which interpretation do we want to use. But you can still use you are always provided with several ways of interpretation. We have also another pseudo R-square in binary logistic regression, which is just like the normal R-squared for regression and simple and multiple linear regression analysis, which tells us how good is our model. Which percent of the predicted, which percent of the independent variable explain to what percent does the variables we included in our model explain our prediction, our independent or our response. And then from there now, we finalize with a new data for prediction. So for example, now when we provide a new data here, we create a data frame in pandas. Maybe this person is in the third class. This person age is 25. This person had no spouse or siblings. This person had no parent on board. That's what it means. This person had 7.25 fair. This person was female, and was female. Yes, here this means that the person was female. And then embarked, this person was not from from Q, but this person was from Southampton. And then now we want to predict. So for us to predict this, we do what? Predict class for the new variable. So we call prediction is equal to the model dot predict the new data. And then the prediction probability, we compute here the prediction probability. So the model dot predict prob for the new data. And then we print this, we print the class. So we want to know in which this person, did this person survived or failed to survive? Is either 1 or 0. So 1 means the person survived. 0 means the person did not survive. So the probability value of the person, if the person survived, the probability value of the person, if you want to print the probability value of the person, you can print to check if the probability value of the person is greater than 0.5, which is just the predicted probabilities here. Where this value 0.63 symbolizes the probability that this person survived, while this one indicates the probability that person did not survive. So the predicted class 1, so the model predicts that the new data point belongs to class 1, so which is the context of the Titanic data. So usually means that the passenger survived. So that is how we can use machine learning to build a model so that we can predict a new entry. When you bring a new entry with some measures, can it correctly classify or can it correctly predict? So that is it. That is what machine learning does. And this is just introduction and one of the models in machine learning. And I will be able to share this, the whole notebook with you so that you can be able to have a look. So this is an introduction to machine learning. Though we have advanced machine learning, the other things that we learned that you can be able also to leverage on. So every model, every machine learning model has its level of accuracy. So some other machine learning models have higher accuracy of their models and compared to the others. So while modeling, you need to ensure that you have the correct, appropriate. You can weigh between models to see which one is having a higher score in terms of accuracy compared to the other one in prediction. So that marks the end of our session today, and also marks the end of our session about Python. But of course, definitely, we have to share resources in the learning management system, share opportunities in the learning management system, and also in our Zap groups, so that we can keep in touch with the Python. Of course, project also has to be submitted within the stipulated time of 2 weeks. So let's try to submit, try to work on it from scratch, work with data from scratch, do a lot of exploratory data analysis that you can do a lot of data manipulation, do a lot of thing you can do that we've learned and beyond the class. So